Okay, in this video we're going to talk more about electron configurations, and I want you guys to start to try out writing out electron configurations, both maybe in a diagram like this, kind of like the ones I showed you before, or also just out kind of by hand. So hydrogen, atomic number 1, will naturally have 1 electron. So to write that, you would just say 1s1, okay? And here you'll see I've clicked on hydrogen. You can see that electron that's in the 1s orbital. Helium, if you go across, is 1s2 because it's atomic number 2. Lithium, right? Beryllium, and you'll see that they're just being added in that pattern. Carbon, nitrogen, now they'll double up. Oxygen, fluorine, neon. And now neon is special. All these elements in this far right column are called noble gases. And they're called that because they've actually got a filled s and p orbital, okay, except for helium, because helium only has, an s at its disposal because it's in the first energy level still. But neon, you'll see, is filled 2s2p energy level. Argon is filled up to 3 energy level, 3s3p, not 3d, excuse me. Krypton, 4s4p. Xenon, 5s5p. Right, and we keep on going. Radon, where are we? 6s, 6p, right? And that's just something that's interesting because when atoms have a filled up s and p orbital, in their outermost orbital, they're particularly stable, right? They're extremely stable, which means that they're actually not going to react with anything. So these noble gases don't react with things. They're called inert for that reason. And it's good to just play around with this. Let me make sure you guys get to see there we go. And this helps you kind of see the pattern in the periodic table. You'll see that these rows here correspond to the last electrons that you have, like the last energy level, right? So those are called valence electrons. So for sodium, the valence electron is this 3s1. And it's because it's the highest energy level one. For sulfur, it would be 3s2, 3p4, right? Because actually all of these electrons are kind of in that highest energy level. For nitrogen, it would be 2s2, 2p3. For tellurium, it would be 5s2 and then 5p4. And we don't really count these D ones in there. You're kind of going by the highest energy level. And again, these electrons are just called the valence electrons. And these are the ones that are going to be able to bond with things. Now in here, these are called the transition metals. In here, you'll see that they'll have an S and a D. All of them will have an S and a D. And sometimes an F, right? If you get down low, you'll get an F too. And we generally would consider, for example, iron. Let's do iron. We would consider the valence electrons to be the 4s2 and this 3d6. So for these transition elements, you also include these d electrons in the valence electrons. Okay, but the general rule is you go to the highest energy level, unless it's a transition element, in which case you include these too. But as you'll see, as you go down the rows, hydrogen's valence electrons, 1s1, lithium, 2s1, sodium, 3s1, potassium, 4s1, rubidium, 5s1, cesium, 6s1, right, and so forth. Francium, 7s1. You see, as you go down this first column, you're all ending in s1, and the row is telling you which energy level. Okay? Now, the second column, you're all going to end in s2, and that kind of just goes down again. And over here, if you jump over here, these will end in P1, and then P2, and P3, and P4, and P5, and P6. Not helium, sorry. Right? And so if I just pick one at random, arsenic, we know it's in the 1, 2, 3, 4th row, so it'll end in 4 something. And it's in this third row over here, so it'll be 4 P3.